Good afternoon, everybody. I'm very honored, actually, to be here. It's very interesting, the first topic. And it was very interesting, the lead-in. It set the bar quite high for me to impress you, right? So, I've come to talk today about the factory of the future, which, in my job and my day-to-day activities at Airbus, is partly thinking about what that would look like. But not just thinking about what it would look like, I also have to spend, I would say, probably a better part of my day trying to figure out how to make it happen. Who here knows what this aircraft is or has been on this aircraft? I see a few hands. So it's the world's largest commercial aircraft. It's the A380. You can seat in a single capacity up to 853 passengers on board. That's the equivalent of about 200 cars worth of capacity. When we talk about magnitude and scale and size of the industry, there's 4 million components that go into this aircraft. Of that 4 million components, there's 2.5 million different part numbers. And those 2.5 million different part numbers are made by 1,500 different companies in 30 different countries around the world. So I need you to grasp a little bit the size and the scale. And I need you to think a little bit about what a factory would look like for such an aircraft and what is the magnitude and the size, not necessarily actually one factory, but factories. And hold on to that for a little bit because I'm going to jump quite a bit forward now. And what I'd like to do is introduce first what we think maybe a factory of the future could look like. So I got a little bit of a video here. If our factory actually looked like that today, my job would be pretty easy, right? It's a little bit more complicated than that. But this is a vision, right? And the vision is something we have to set as our ambition to strive towards what we want to see in terms of our production facilities and how we build the aircraft. But to talk a little bit more about what to do with regards to making that happen, I need to try and give you a little bit of a background into what the aircraft assembly process looks like. Has anyone ever been in an aircraft manufacturing facility? Okay, so you guys have to come up here, right? I need you on stage to explain to everybody. No, don't worry. But I may ask you some questions. So where were you again? Okay. So we talked a little bit about the size at the beginning, right? With regards to an A380, for example. And I like the introduction when we were talking about feathers. Well, with an A380, we're flying somewhere in the range of 260,000 tons of feathers. I mean, it's taking off, it's landing, it's cruising. So the magnitude and the scale of the size of the infrastructure that we need to put these aircraft together, it's quite large, it's quite big. And it's not something that's just automatically fitting itself together. There's a lot of people involved in the process. There's a lot of measurements, there's a lot of checks, there's a lot of controls, there's a lot of ensuring that everything fits and goes together correctly time and time again. How many holes do you think we drilled in Airbus last year making all of our aircraft? Throw a number. Give me one at least. How many? More than 6,000? 120 million approximately. 120 million approximately. Actually, on an A380 to join the three sections together, I think it's somewhere in the range of 13,000 holes just for that, and 4,000 when we join the wings to the aircraft. So what you need to know about that is that because of the quantity and the magnitude of that is, it's not a bunch of robots running around drilling all those holes. This is way, way too complicated today for today's existing automation to do. So it's people. It's people that are doing that. And they're doing it also at a very high level of standard and quality to make sure everything fits together correctly. When you have 4 million components that you have to assemble and then fly this 260,000 tons off, it has to work perfect, right? Another complexity that you add inside an aircraft is, and you never really see this because in the amazing cabins and the comfort that you have inside the aircraft, there's a lot of wiring in behind the coverings. I'm going to ask another question. How many kilometers of wiring do you think we have on an A380? Kilometers, yeah. 100, 50, 300? 300 is getting close. 500 kilometers on an A380 of wiring. So again, keep in mind, how do we put that into the aircraft? How does it get there? And it's an engineering feat, what we pull off and what we do. Painting. Painting's another perfect example of one of the process steps that we go through in building and making our aircraft. And again, people are at the heart of the process. Assembling, fitting, we have thousands and thousands of different process steps that go into making a modern day commercial aircraft and making it fly and making it work correctly. And what we have to think about with regards to these challenges is, well, and maybe I'm hoping maybe someone has some help they can give me, because I really would love to know how I can answer this in front of my boss. So afterwards, a little bit of a quiz, maybe I'll ask the questions instead. We have to think about how do we transform such an element in such an industry with regards to what was being mentioned at the beginning, new technologies, the innovation that's going on outside. Maybe it's not new technology, maybe it's technology from 100 years ago that we haven't thought about. So these are the types of questions that we're thinking about when we're looking about how to get towards our factory of the future. And if we look at the state of the art today, if we look at another industry like the automotive industry, and you think about our challenges, here is what would be considered cutting-edge automation in automotive. Now, remember the size, right? So this is a car, and I have at least 6 very, very heavy robots that weigh probably anywhere from 2 tons per robot. They're performing, so they're big, right? The robots are big. They're quite heavy. They're performing, in this circumstance, 2 tasks, probably. Primary task is they're welding pieces of the car together. So these robots are doing 1 or 2 things in a very repetitive fashion over and over again. Now, what can I do with that? I mean, I have thousands of different tasks to manage, and they're all different. The other thing with this is the car comes to the robots. Now, if I have to bring my aircraft to the robots every time I'm going to manufacture it, I'm going to have some logistical problems also. And safety. I have a lot of people in our production process. These robots, you don't want to be near these robots when they're working because they're not having any intelligence of any kind, and they're not safe for people and for humans. So what do we do about that? And this is the common theme of the question we come back to again and again when we're trying to figure out what to do with optimizing and making our production processes more efficient. The trend, we talked about internet, the connectivity of objects. I mean, I don't probably need to spend much time explaining to you the trend of what's moving in terms of computing power. Computing power, what you carry around in your phones today. I was having a conversation, I think it was last week, about internet access. And a friend was asking, how did we access the internet in the 90s? And I was like, what I remember is I had to go to my university, I had to go into a special room, get access to a specific computer, and access the internet. And before coming here today, I'm like, I'm frustrated if I can't get onto the internet anywhere I'm going, whether it's in the car, whether it's in the hotel room, because of the connectivity that we get adapted to. So this is a lever also for us. So when we focus, at least in our industry, with regards to what we do to modernize the way we're working and to make things more effective, we start from the person. And we start from the person and the worker because we have many of the workers inside our factories working and building these very amazing and high-tech aircraft. And we work on, in this case, how do we get the right information and the right data into the hands of the person at the right time, knowing that he has maybe a number of different process instructions or work instructions that he has to read depending on the job he's doing, then he moves to a different job. So, you know, you're moving from one activity to the next. It's not like the automotive where I can set somebody down, you're going to do one task day in, day out. We have a lot of diversity to manage in our production processes. We take things, and this one is an example. We deployed, I believe it was the end of 2011, the modern aircraft we have, whether it's our A350 or our A380, they're designed in 3D data by our engineers. So we have 3D models, we have 3D mock-up. And what we do here is we just took that, we were able to plug in an augmented reality module to be able to overlay the design world with the physical world as it was happening. And in this case, and the number we have is this one was used to check the brackets. Remember the wiring I said? Lots of wiring. You have to hold that wiring in the aircraft. So we have lots of brackets. And in this case, we were able to cut the checking process because if we had 60 to 80,000 brackets to hold all that wiring in place, the manual way we had to ensure during the production process that it was all there took about 3 weeks. With this simple device overlaying what the design was versus the physical world, we were able to do it in 3 days. Again, around the worker, we're optimizing. It's not replacing him. We're optimizing what he has as a tool to use in his day-to-day job. Automation. So the way we have to approach automation is also a very interesting lever to see how we can put it, even though the other picture I showed was these big robots. They're not very friendly and they're not very easy to adapt into our production area. So we're looking at lightweight, collaborative systems that are safe and that can operate with our staff. And they're able to do it in a way that they're assisting the operator. They're working hand in hand, they're working side by side. So this is something also that we're spending a lot of energy to figure out what we can do. And this one actually here is expected to be in production trials end of this year. Another example of that is here. So it's not the most complex task we've started with, but there's an evolution that you have to these types of activities. There's a lot of complexity that goes on behind figuring out how to take whatever system and apply it to the complicated product that we're building. And one of the things that you can't see in this picture, but it's probably more important than any of the technologies, any of the little bits that I showed you, is if we're to take such an approach and if we're to capitalize on the wealth of knowledge that exists in the globe, in this room, in this city, in the universities and companies, we don't necessarily have to think, and this is the approach we're trying to work on, about what exactly is the solution, but we need to know what our problems are, and then we focus on this technical framework on how we want to be able to tell whoever it is the language, especially when it comes to the digital age, the digital language that they need to use to plug into our production systems. Because the real difficulty in a lot of that setup, whether it's a robot, whether it's a tablet, whether it's a drilling tool that we've put some smart chips and information into, is that information needs to flow and that information needs to travel into a system, and there needs to be the brains behind, and you don't want to reinvent every single time how you learn or teach the information to move into the system. So we've started working on this building block, and the concept there is to take this technical building block, call it the way we communicate. If Airbus is the world and the rest of the world's outside, we define a boundary between on how we would like the rest of the world to communicate with us. And then the approach is, as opposed to what we do a lot of today when we look for innovation, we see something that's going on in the world and then we go to it. And then we're like, man, how did you make that happen? And we try to understand it. And we do that also in our industry. But it's kind of like searching for a needle in a haystack. You know, you're always kind of a few steps behind, or it's difficult to understand where you need to go to search out opportunities. So we're looking for a way to switch that, reverse it. How can we describe what our challenges are in our industry? How can we set that framework? And how can we then leverage and make it known to everybody that there's opportunity? There's opportunity for them to come and maybe work on a problem and maybe come from a complete different industry, because there's also a lot of crossover that can happen when we do that. That is the approach, and what we've started to see is we start to have success in certain aspects of how we can apply that approach. And it's, in my view, when we lay down the foundation that we're talking about, when we lay down those process steps and progress steps to start to make it happen, and we start to explore other opportunities in the way to make it happen, and have this very strong dialogue with the world in terms of ecosystem of knowledge and information, that we actually have the chance to make something like this happen. Thank you.